Hello and welcome to the walking talking topic on bounds and estimations, question number 2 with me, Mr. Barton. Now this is a meaty 7-mark epic of a question that's flipping hard, so we've got to make sure we break down everything it's saying, get ourselves possibly some little diagrams on the go and see how many of these 7 we can get our hands on. Okay, we've got a handrail alongside a straight path is 60 metres long and measured correct to the nearest 10 centimetres. Now that is going to be very, very important, as is the fact it's 60 metres long. Thin strips of metal of length 40 centimetres measured correct to the nearest centimetre are attached to the end along the top of the handrail. These metal strips must cover the whole length. That's going to be important as well. What is the minimum, so the smallest number of metal strips required to guarantee? Now that's going to be very important. We've got to absolutely guarantee that we can cover it. So when I see guarantee, I always think worst case scenario. Right. I think a diagram is called for. Now I'm the world's worst artist, so let's try and keep it as simple as possible. So let's get ourselves a handrail. Here he comes. Beautiful. Hope you can picture that there. And that is 60 metres long. There he goes there. Correct to the nearest 10 centimetres. Well, in fact, if I'm dealing in centimetres, I'm going to already change that. I think instead of 60 metres, I'm going to have that in centimetres. So 6 metres will be 600 centimetres because 1 metre equals 100 centimetres. So 60 metres must be 6,000 centimetres. Now we'll worry about this nearest 10 centimetres in a second. I just want to get a picture of what's going on here. Thin strips of metal of length 40 centimetres are attached. So let's draw one of these things on. Now this is definitely not to scale, but this might be a little thin strip of metal. Again, I'm wasted here, I should have done art. So that there is 40 centimetres and they're attached and they must keep coming all along there, so you might get another one there, 40 centimetres, and they cover the entire width of the handrail. Now what's the minimum number of these you need to guarantee the whole length? Well, if there was nothing about how they're measured, we just do 6,000, which is the tire length, and we divide it by 40. So I'm just going to bang that into the calculator just to get a sense of where we are here. So let's get my calculator. 6,000 and divide it by 40. So that's going to be about 150 strips, but that isn't going to guarantee it because we're not sure that this handrail is exactly 60 metres and we're not sure these strips are exactly 40. So let's think what these strips could actually be. Sorry, what this handrail could be. So 60 metres long, 6,000 centimetres is the nearest 10 centimetre. What's the upper and lower bound of that? Well, this is the way I like to do this. 6,000 slap bang in the middle. What's its upper bound and what's its lower bound? Well, if it's measured to the nearest 10 centimetres, then I think the width of this bound is going to be 10 centimetres as well. So I think the longest it could possibly be is 6,005, because any more than that, and it's going to round up to 6,010 centimetres. And likewise, I think the smallest it could be is 5,995, because any smaller than that, and it's going to go down to 5,990. So that's my scenario there for the handrail. What about these little strips of metal? So they are 40 centimetres and they're measured to the nearest centimetre. So again, let's get myself a little diagram on the go here. And again, I think that this boundary is going to have, this bound is going to have a width of 1. So if I want it to be as long as it possibly can, I think it's 40.5, because any more than that, and it's going to round up to 41, which wouldn't be 40. And likewise, the smallest it's going to be is 39.5. Any smaller than that, it's going to round down to 39. So the question we're left with now is, how do we make sure we guarantee that we've got enough strips? Now, this goes back to what I mean about worst case scenario. We want the scenario that gives us the most strips, the worst case scenario, because that means we guarantee that we've done it. So we're going to need to do the 6,000 and divide it by the 40, but we now know that 6,000 could be anything as high as 6,005 and anything as low as 5,995. So what's going to give us the worst case scenario? Well, the worst case is going to be if this path, this handrail, is as long as it possibly can be. And the worst case scenario is going to be if these pieces of whatever they are, metal, are as small as they possibly can be. So 39.5. And if I bang that into my calculator, 6,005 divided by 39.5, I end up with, now that's not come out so nice, so I'm going to have to press my little SD button, 152.0253 da 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 da. Now, if you're thinking, well, can I not get more than that? Can it not be a worse case scenario? Just try out a few. Like if you try 6,005 and you divide it by the upper bound here, 40.5, and you bang that into your calculator, 6,005 divided by 40.5, you'll find that it doesn't come to as much. That's only come to 148. Well, that's better, but it's not the worst case scenario. So this is going to be our answer here, 152.02. But what does that mean for the minimum number of metal strips? Well, if it is the worst case scenario, then 152 strips isn't going to be quite enough because we're going to have a little bit of this handrail left over. So unfortunately, we're going to need 153 strips in total to fill it. And if you set it out nicely like that, and if you label these as your upper bound and your lower bound and your upper bound and your lower bound, then you're making it crystal clear exactly how you're doing this, and you'll get yourself 7 lovely marks.